So good morning, everybody. What did we discuss yesterday? We will continue from there onwards and we will start talking about a new topic, which is neural networks. So just give me a second. So yesterday we are talking about regression models or regression algorithms, which is present in supervised. So let's once again, let's see how to do it in RapidMiner Studio. Then we'll move on to the new topic of neural networks. Okay. So let me open for you the application that we are using. So here is our like a tool that we are connected with, which is RapidMiner Studio. Here we are going to deal with, first of all, regression, because yesterday we talked about regression, linear as well as logistic with the help of example. Let me show you one more time. Then we'll move on to neural networks. So here, this is our like a tool. And here I'm going to create a blank process. So this is the blank process here. Now, what is that? Yesterday we have discussed about linear regression. When your output variable is numeric or categorical, based on that, you will use either linear or logistic regression. So let's see here first. I'm going to use the golf data set, which is present in the samples folder in repository panel. So under the samples folder, you can see a lot of data sources coming, which are the default data sets which are already there. So here under the data folder, you have goals. Take that into the process. After taking that into the process, what you have to do, you have to understand about your data. What is your output variable? How many input variables are there? All those things you have to understand. So in order to understand what you have to do, you have to execute this process. How can you execute this process? By establishing the connections. Now the connection is fine. Now execute this process. Now, how many columns and how many records are there in this data set? So there are totally 14 records and 4 columns, which are regular columns, and 1 special column, which is the output variable. So here there is a column called play, which is categorical data. But I want to perform linear regression. When can I perform linear regression? When my output variable is continuous. But here in this case of golf data set, my play, which is the output variable or label, is not continuous data, which is not in numbers. This is present in categories, yes or no, which means binary data. I can't go for linear regression when my output variable is binary. Then what I have to do? In order to apply linear regression, I have to go for converting this categorical into continuous. You can do that in many ways using numerical to binomial, all those data types or operators present. Or I have also shown you yesterday a new operator, that is generate attributes. So as the name indicates, attribute is nothing but column. We are generating a new column. How? So see this, I'm taking this into the process. Now, what is the mandatory thing? The connections should be established between the operators. And then what? I have to create a column so that I have to customize my particular operator, generate attributes. How to customize this operator? You have to use the parameters present for that operator. So click on generate attributes, go to the parameters here. You can see on the right hand side, edit list coming. Click on edit list. And after that, name whatever the new column had to be according to your requirement. And what is the function? What is the formula for the new column? You have to write it here. So I'm just writing my new column as play, which I am encoding, which means encoding we already discussed. That is converting a categorical data into continuous data or a column. Anything is fine. So play encoded is my new column name. And what is the function that we have to take here? You have a column, which is the output variable, that is play. What is the output variable for you right now? That is play, but play is present in category. So play is the label or the output variable present, but this is in categorical data. In categorical also, this is binary because you have yes and no. That is binary data. Now I am just encoding these into numbers. Encoding is nothing but converting categories into numbers or categorical data into continuous. Now what I do, I just want yes to be 1 and no to be 0. Wherever I have yes, that record should have 1. Wherever I have no, that record should have 0. Now how to write here the formula for that new column coming? So see here, I will just click on this calculator button that you can see on the right side of this particular blank space. Click on this thing, you can see a lot of different functions coming. You want to use logical, or you want to do the comparison, or you want to work on text. You can have a lot of different functions present. You can use whatever you want according to your requirement. Right now, our requirement is wherever I have yes, it should have 1. Wherever I have no, I should get 0. So I have to use conditional function, which is logical. So I will go to this drop down of logical. And within this again, you have a lot. I will use if condition. Now, what is my condition here? If play, which is the output variable, is equal to yes, you have to check properly what is the like a case sensitive. Like this is case sensitive. You have to check whether it is in lower case or upper case. My S and no are in lower case. So I will write everything in lower case in double quotes. Why double quotes? Because that is the string. So if the play value is having yes, I want to convert it into 1. If it is not yes, obviously it is no. I don't have to write another condition. I will directly write 0. This is my condition here. If play equal to yes, then I should get 1. If not, I should get 0. If you are satisfied with this, whatever that you have written, just click on apply at the bottom. And again apply. And check it out what is happening after you execute this process. So the connection is missing. Establish the connection properly. Now check it out. You have a new column added, which is play encoded. So wherever you have no, that is represented as 0. No is there, so that is 0. No is there, that is 0, and so on. That is how I have encoded using which operator? That is generate attributes operator. This is the new operator which we haven't discussed about before. This is the new operator in order to generate a new column based on your desired requirement, based on some conditions or functions. This is what we have. And then after generating the column, what I have to do now? Now, I want to apply linear regression. So as we talked about linear regression, it should have the output variable to be numeric. Okay, I got numeric, this particular column, but I want to make it as output variable. Now this should not be output variable. This should not come in green color. The play encoded new column should appear in green color because this is my output variable. Now for that, in order to make a column regular or a label, which operator we have to go for? We have to use set role operator. In order to make an operator label, which is output or a regular, you have to use the operator here, that is set role. So how to use set role operator here? Just go back to the design phase and in the search of operators component, just search for set role operator. Just take it into the process. Always the connections are mandatory. That is what I'm telling you from the start onwards. The connections between the operators is mandatory in order to execute your process properly. Now, I want to make the play encoded column as output variable. How to make it as output variable? You have to obviously go for parameters. So check out the parameters for the new operator that we have taken. What is that operator? That is set role. So go to set role, parameters option on the right hand side. Now what? Now I want to make the play encoded column as label variable or label column or a target variable or an output variable or a dependent variable. You have to know the terminologies here. So play encoded column needs to be output. And if you want to add one more, you can add one more. I will make play as regular. Now play column before it is a green colored column, which is a label column. Now I am making play encoded as label and play as regular. And click on apply and check it out whether it is properly present or not. Now, if you see the output variable is properly represented according to my requirement, which is play encoded column, and play column is regular. Now, what I do, I will just use or I will select only two columns out of all these columns present. What is it? I am going to show you, first of all, simple linear regression. When do we go for simple linear regression? What is the requirement that you should go for simple linear regression? So I have the supervised machine learning algorithms within which I have regression models, in which again I have linear and logistic. In linear again, you have two types, simple linear and multiple linear. Okay. In the simple linear regression, what happens when should I go for the simple linear regression? When my output variable is numeric or continuous, anything is fine. And when I have only one input variable, only when I have one input variable, I should go for this simple linear regression. But I have multiple inputs here, outlook, temperature, humidity, wind. All these are inputs. Only one output variable, but multiple inputs are there. But how can I use the simple linear regression? Now what I do is, I will select only one input variable and one output variable. That is nothing but simple linear regression. How to do it here? How to select the desired columns or attributes, one input I want and one output I want. So how to do this here? You can go for the column or the operator called as select attributes. You can go for select attributes operator. You can select whatever the columns that you want. So how to do it? Go back to the design view here. Go back to the design view and check the option which is select attributes. And take it into the process again. And always, as I told before, it is mandatory that you should have connections established between the operators. Between the operators, and then what? I have to select my required columns out of all. Then I can go for parameters. So here, click on select attributes operator, and I want to include the attributes. What are those? A subset, that is not one. I want to include two. What are those? Select here. This is not properly present. If that is not properly coming, once again execute the process and check out the columns and again take this. Sometimes it happens. So I want to include a subset of columns that are, first one, I will take the output variable obviously, and based on which input variable I want to predict my play encoded, whether I can play or not. The golf, whether I can play or not, based on what? You can go for humidity, you can go for temperature, outlook, anything is fine. I will show you the first one, temperature. Okay, click on apply. I've selected one input variable and one output variable. As I have one input and one output, I can go for simple linear regression. Before going for simple linear regression, what happens in a supervised machine learning algorithm? In a supervised machine learning algorithm, the data gets randomly split into two parts. One is training data set and second one is testing data set. So how to split your data in RapidMiner Studio? I told you yesterday which are the operators that we have to use here. The first operator that you can use is split data. The first operator that you have that you can use for splitting this is split data. And the second operator, what is the second operator present? The second operator that we have is cross-validation. These are the two operators present in order to work on supervised machine learning algorithms. Why am I telling supervised only? Because in unsupervised, the random sampling or random splitting of data will not happen. Okay, so here see what I do is, first I will show you the split data option. First, I will show you the split data operator. So go to this operator search bar and search for split data operator. Take this into the process. Take this into the process. Whoever is doing that, just stop it. So split data, what I have to do, I have to split my data into two parts, which is one should be 70% and another one should be 30%. One should be 70% and another one should be 30%. So how to do it? How to do it? I have to go for again parameters. As I told before, split data will not automatically create your partitions. You have to manually do it. How to manually create the partitions? Just click on this operator and go to this parameters option and enter whatever the partitions that you want. One should be 70% for me and another needs to be 30%. Click on OK. Now I've splitted my data into two partitions. One is 70% and second one is 30%. Now what happens? I have to take my 70% of the data into what? Into my algorithm, which is linear regression. Take this operator into the process. I've got it. 70%, the first part goes into the algorithm. And after that, the output of this linear regression goes into the operator, that is apply model. The result of linear regression goes into the operator called as apply model. And not only that, the remaining 30% that we have in our split data also goes into this apply model. And after that, if you want to measure the performance, you can go for measuring the performance. You can check it out, the operators that you are getting at the bottom. You can check all those things. And establish the connections, which is the mandatory thing to do. After establishing the connections, just execute the process. And execute the process how? Click on this play button here. You will see here, this is the performance and this is the apply model. So this is play encoded and this is the predicted play encoded. This is what you will get when you are applying linear regression algorithm. So linear regression is preferred when you have a single output variable which is continuous and when you have a single input variable, whether it is continuous or discrete, that is fine. Then you will go for simple linear regression. This we have seen yesterday. And what did we see yesterday? What else did we discuss? So you have to understand the usage of every operator. That is the mandatory thing in this particular tool. You have to get a grip of all the theory topics. Which one is used for which purpose? Once you understood about the theory, you can go for this particular tool usage, but you have to understand which operator you need to use for which type of data, or which I have to go for which one for this prediction process. For supervised algorithm, for this model, I have to go for which type of operator. All these things you should be clear about. Then this tool is very easy to work with. Okay, so let me show you one more thing. Here, I'm going to show you one more thing regarding the linear regression itself. For this, I'm going to use the operator read Excel. For this, I'm going to use the operator read Excel. Now, in order to import your data from this operator, you have to click on this operator and check out which of the file that you want to import here. I want to import the multiple linear Excel file that I've created. So multiple linear, when do you go for multiple linear? When you have an output variable that is continuous and you have multiple input variables, then you will go for multiple linear regression. Now what to do? Just click on next and see whether there are any formatting problems present. You can check out at the bottom. Here, if you see, there is no problem in my formatting of the data. Everything is there fine. Now I will simply click on finish. Now everything is fine. If you want to look at the data, what to do? You have to make the connections and execute this process. If you see here, there are totally 20 records and 4 regular columns. Nothing is an output variable here. And everything is numeric. So one output variable is there that is continuous. And multiple inputs are there, which is also continuous. So I can go for multiple linear regression. So what to do? First of all, you have to set a particular column as your output variable. So what is the output variable here, which I have? That is target column. Target column is my output variable. So what to do here? I have to use the operator called as set role operator. So take this operator into the process. And what is the mandatory thing? You have to establish the connections. And after that, in order to make work of this one, you have to first go and customize this operator using its parameters. So set role operator is there. I'll go to the parameters of that and I will check the target column as the label and click on apply and execute this process. Now, if you see, the target is the output variable and remaining feature 1, feature 2, feature 3 are inputs. I have multiple inputs. I have a continuous output. Then I can go for multiple linear regression. Before applying any algorithm in supervised machine learning models, you have to split your data. So for that, I told you before, you have two operators. One is split data. I'll show you both of those. Split data here, which you have to manually make the partitions using the parameters. And what about the cross validation? So I will show you the second one. See, that is cross validation here. Cross validation will automatically creates the partitions. So what you have to do in order to make it work, just simply double click on this. You will get two partitions, training and testing. In training, what you do, you will take your algorithm, that is linear regression, and the training data partition goes into this operator as input, and this should be output to this next column or next phase. And what is there in this phase or in this testing data? You have the operator, that is apply modal operator. Just take this apply modal here and make the connections here properly. And if you want to measure the performance, you can measure the performance. Performance regression. So you have to check it out clearly. Performance needs to go to performance and example here. And after that, if you want to go back to the process, you have to click on this process at the top and you have to make the connections. After everything is properly connected, you have to execute the process. Now, this is your root mean squared error, the performance, and this is your linear regression, and this is your set role, and this is your history and cross validation. Everything is shown properly. This is the target and this is the predicted value. So how you will get accuracy? When we measure or compare these two values, you will get the accuracy. You already know all those things. I don't want to discuss about it. So this is how you will use this cross validation. If you don't want to use it, then simply you can go for the easy one, that is split data. Take this into the process and double click on it. You will get this parameters. Now first, what is my parameter? 70%. And what is the second parameter or second partition? That is 30%. Click on OK and execute this process. So you got two partitions. Now what? Now we have to apply the linear regression algorithm to the first 70% of data, and the output of this goes into the operator called as apply modal. And then the split data 30% remaining data also goes into apply modal and take the performance and make the connections and execute the process. Now, this is the target value. This is the predicted value. There are almost same 450, 450, 380, 76, 680, 670, 890, 891. They're almost similar. And when you measure the performance, this is the root mean squared error, which we talked about before. And this is my linear regression. This is the linear regression. So this is how you will execute simple linear regression as well as multiple linear regression. For both of those, we have only a single operator present here, which is linear regression. But what is the difference? When I have the output variable continuous, I will obviously go for linear regression. But when should I go for simple? When should I go for multiple? Depending upon the number of input variables. If I have a single input variable, I will go for simple linear. If I have multiple input variables, I will go for multiple linear. So this is the second one that we have. And we will talk about the logistic regression and we will move on to the new topic. So how to work on this logistic regression algorithm or logistic regression? How to make it work? So first of all, I will show you an example of ordinal logistic regression. So what is ordinal logistic regression? We talked about before ordinal data, what is ordinal data and what is logistic regression. So for this, I will take the Excel file that is using the operator because I don't want to save it in my repository. So take this into the process. After this, how to import your desired data? You have to double click on this operator and select the data set, whatever you want to import here. I want to work on ordinal logistic Excel file. Just take that Excel, click on next and check out the format if you want. See here, there is no problem in my formatting of the data. So I'll simply click on finish. Now I got this data. Now what? Now I want to show you the concept of logistic regression. Before that, check out what is present in this data set. So if you see there is a target variable and this target variable is having categorical data. What is it? This is having categorical data, but this is not having two categories. So basically what we say is logistic regression is used when we have binary data, which is categorical output variable. So what I do here is I will convert this particular column, which is having three categories. What are those three categories? So I have a column called as target, and target column is having three categories. What are those? One is low, second one is medium, and third one is high. These are the three categories present. Now, I want to make it binary. How? What I do is, I will again write the condition. What is my condition? If it is high, then I want to remain or retain it as high. If it is either low or medium, then it should be low. This is how I want to convert my three categories into two categories. For this, which operator I have to prefer? I have to prefer, in order to create a new column based on condition, that is generate attributes. As the name indicates, I am generating a new column. So how to use this? How to work on this? So just go to the design view and select the operator that is generate attributes. Take this operator into the process. And the main important thing over here is you have to make the connections properly between the operators to work. So click on this operator generate attributes. Now go to this parameter section. And here, what is my column name? My column name, I will give it as target variable, which means it is already target. So I will write it as target, which is a new column. And what is the function? What is the condition? See here. I will go click on this calculator symbol and I will select logical if condition. If what is my column name? If target is equal to high, then I should have the output as high. Otherwise, what? Otherwise, I want to have the output as low. This is my condition over here. If my target column is having high as the record value, I should have high again in my new column. If it is not high, which means what? It can be either low or medium. If it is any of those, I should get low as output. Simply click on apply and again click on apply. Now execute the process and check out what is that. So what a new column target new. Wherever you have low and medium, it is low. Wherever you have high, it is high. Now done. Now, in order to work on a supervised machine learning algorithm, you should have an output variable to be specified properly. So what is it? What is it? Before doing that, I can go for selecting the attributes. So if you want to select few columns, you can go for selecting the attributes, but I don't want to select anything. I'll simply go for setting the role. I will select or I will just work on the select rule. Sorry, set rule. Now what is it? I will just select what is the column? Target new column as a label. Target new column as a label and click on OK and execute the process. Now what happens? All the remaining 4 columns will be regular columns and one column, that is target new column, which we have created before, will be the target variable. Now I don't want this target column to be there. I don't want to analyze my data based on this column. Now, in order to exclude that attribute, I have an operator called as select attributes. Take it into the process. Now what? You have this one where you can select exclude attributes in the parameter section of select attributes operator. Now what? I want to exclude only one, which is target. Not target new, that is target. Okay, target is fine. If you don't want to just write it down, you can select it from the drop down. Anything is fine. Now, when I execute this process, what happens? It will show me only 4 columns. One is target new and remaining 3 are input variables. So see, I excluded target column. Now what? As this is a logistic regression, which is supervised machine learning algorithm, I have to split my data, which is the obvious thing you already know. So split data here and edit new enumeration here and add entry one is 70% and another one is 30%. Click on OK. Now, 70% of my data goes into which one, which operator? That is logistic regression operator. Now take it into the process. 70% data goes into logistic regression and remaining 30% goes into apply model. So first the output of logistic regression goes here and remaining 30% also goes here. Now what? Now everything is fine. If you want to get the accuracy, check out the performance operator here. Just make the connections properly and at last connect these to the response port and execute the process properly. So this is the performance. If you see here, this is the target new, the predicted value and the confidence intervals. And this is the accuracy, which is 100%. Everything is same, properly matching. So this is how I can go for logistic regression over here. This is logistic regression. So there are multiple things that you can go for. There is polynomial regression operator also. There are a lot of different operators present, which is very much important for you to understand the purpose. What are the inputs for each and every operator? And what does that operator gives us output? Everything is mandatory to understand in order to work on it in real time. So here, if you want to get an understanding of which should be the inputs and what outputs it will give me, if you have any confusion regarding that, what you have to do, you have to right click on operator on the left hand side and click on the first option, show operator info, within which you will have a description present. You can check it out here. What is that purpose of the operator and what is the description and which input I have to give, which output it would give me. All these things are present clearly under the description of every operator. You can check those out. Next, let us move on to the next thing. What is present in the next slide in our presentations? Let's check it out. So here our slides are there. In the previous session, we have ended regarding the lasso and ridge regression, which we have talked before. And also I've told you ordinal logistic and multinomial regression. Everything is finished. We have worked as well. Now the next thing that we have is deep learning and AI. So what is this deep learning and AI? Why we are about to talk about this? Okay, so we are supposed to talk about this. Let me just make it bigger. So here, we are supposed to talk about artificial intelligence. And how do you build artificial intelligence applications using deep learning? So here we are supposed to talk about what is it we are about to talk about AI. You already know about AI. You may have heard that word multiple times. AI is nothing but artificial intelligence. And how can I build artificial intelligent applications using the concept called as deep learning? How can I do that? A lot of AI applications that we build, especially audios or images or textual data, etc., any data it may be. People are using the concepts of deep learning in order to build those AI applications based on this data. So when it comes to deep learning, we have a lot of libraries which exist. And some of those libraries are provided here. That is, in Python, you have a lot of things. Deep learning with PyTorch, TensorFlow, and Keras, OpenCV, Cafe, all these things are libraries which we have. Out of which the PyTorch and OpenCV, TensorFlow, Keras, these are most widely used for deep learning concepts. These are the most widely used. And here, if you see OpenCV, this stands for computer vision. CV stands for computer vision. And this is useful for handling image related applications. So each one is having a specific purpose for everything. So if you see here, these are the different libraries that we have in order to deal with deep learning concepts. Why we are using deep learning concepts? In order to build artificial intelligence based applications. And they may be related to audio data or image data or video data or textual data, anything it may be. Everything comes under this deep learning concepts, out of which we have a lot of libraries in which OpenCV is there, which is handling image related data or applications, and CV stands for computer vision. CV stands for computer vision. And then what? Okay, these are fine. Then what is there? The next one that we have is AI preventive maintenance. So while you are using traditional machine learning algorithms, which you have learned until now, deep learning is used to handle complex data. What is it? Until now, we have talked about a lot of traditional machine learning algorithms. So out of which we have learned all these things, but currently we are talking about deep learning. Why we have to learning deep learning? We have already learned these algorithms because it will handle the complex data. It will handle complex data. So when you feel like your regular algorithms are not working properly, if you're feeling like your regular algorithms is not giving you the proper output, then you can simply go for deep learning algorithms. So let's see an example for this one. So that is present over here, AI preventive maintenance. So if you have a manufacturing plant, so see here, let's see what is present in the slides. So if you have a manufacturing plant and you are continuously using your machines in order to manufacture something. So there is a manufacturing plant. It is manufacturing some product. You are continuously using your machines in order to manufacture. Now, there will be a lot of wear and tear. So what happens? The components of your machines might become faulty. And thereby it lead to the failure of the entire equipment. Why would that happen? Usually all the manufacturing units are sequential in nature. So you will have to continuously monitor the critical components of your manufacturing plant. So there will be a lot of components present in your manufacturing plant, but there are some components which are very critical. First of all, you have to figure out what components are critical. You have to figure out what components are critical and what components are non-critical. And then you need to ensure that all your critical components are working properly. If they fail, then the entire plan stops working. What is it? Everything is sequentially connected, all the components, and you have to monitor and understand which components are critical in use and which are not critical. And after, you have to ensure that all your critical components are working properly. If they fail, your plant will stop working. You need to figure out how to capture the data. In most cases, we will have the IoT sensors. You may have heard about this before. You have a sensors called as IoT sensors. So what are those devices? What are those? So these are the devices which transmits the data over the internet. So these are the devices which transmits the data over the internet. So if you have sensors which are well and good, then it's fine. But if you don't have those sensors in place, you have to get an IoT expert who would install the device and they set up the sensors. And from those sensors, you will get the data. So this data, where can you store this data? Coming, either you store it in on-premise or anywhere else. You already know about on-premises and all. That is what happens in a manufacturing plant. So this manufacturing plant, in this, there is a specific engine. There were few sensors. It was related to a component called as compressor. It was related to a component called as compressor. Once you collect the data, you can process the data. You got the data. Once you collect the data, what you do, you will process the data. And after everything, you will make predictions about your data. Once you have understood these things, you can take the decisions. This is one project pertaining to the manufacturing plant. So let's see what is there here in the slide. So there is a manufacturing plant. Customer systems migrated with an industrial company. Sensors are there. And sensor is present. Sensors relay critical information on compressor usage. And there may be wear and tear. This is connectivity here. The collected data is processed to analyze usage, forecast something, and also make some decisions. So you can just store it on premise, which is cloud. And compressor usage and performance is related to centralized industrial company, customer service team, and shared with the customer via apps. So this is what you have an example of this particular thing, which is artificial intelligence applications. So let's see what is present. This is one example manufacturing plant in which you have IoT sensors, and IoT sensors basically capture the data. Once you do that, you will process it and make the predictions. So that is AI related one thing, which is AI preventive maintenance. And the next one that we have is one more project, that is AI predictive maintenance. This is related to vehicle breakdown. So this is related to vehicle breakdown prediction. So what we do here is we have placed IoT sensors and we capture the data. We place the IoT sensors and we capture the data and we place or store it on premise, which is on cloud. And we started predicting whether a vehicle breaks in a specific journey or not. Which component will exactly break? After how many kilometers does the vehicle brakes? All these predictions I am making based on the data collected. We have also encountered a specific problem while doing this project. That is, your sensors have a SIM card which you put on your mobile. See here, that is properly present in this example shown. You have some SIM cards which you have put on your mobile that you are connecting it to TCU, that is telematics controlling unit. What if the truck is moving to the region where you don't have the network? And if the network is not available, how do you get the data? How do you even get the information? That the truck breakdown or not, how can I predict it without the data present, without the network present, because the SIM card is not working because of improper network, unstable network? Then what to do? Then probably maybe after 600 seconds, there is no signal. What is that? Imagine I'm just traveling for 1000 seconds. After 600 seconds, I don't have any network. I don't have any network. So are we saying that that these 1,000 seconds data is gone because of improper network. One classic way to do here is you can go for imputing the data. Or another thing that I can go for is you can forecast the data. Even if we are not receiving the data, we will forecast. There is a company who is specialized in setting up all these things present. Okay, that is some other example. But in this current example, predictive maintenance, we are making the predictions even though the network is not there. Why we are talking about network? Because here there is a connection given, which is TCU, telematics control unit, a SIM card is present. If there is no network, I can't collect the data. If I can't collect the data, how can I make the predictions? For that, one classic way that I have is imputing the data, and another way is I can go for forecasting the data. This is one more thing, that is AI predictive maintenance. So let's see what is present in the slide. So here see, data packets transmitting from device via telecom operator, data stored onto cloud, improved TCO, two-step algorithm, assemble and survival analytics. Descriptive and predictive analytics. Predict exactly on how many days will the vehicle run efficiently before the breakdown. This is what we want to predict. Predicted vehicle breakdown based on heartbeat data and heartbeat streaming data while vehicle was on move. Historical data from OBD for service and breakdown vehicles. All these things we are predicting under this particular example, AI predictive maintenance. Next, what is that? Next, what is that? The next example, let's see the next example. The next example is related to a smart factory, which is hospital. There is a company who is specialized in setting up smart hospitals. Here is also, there is a lot of artificial intelligence, lot of sensors, and lot of clouds involved. Now, what we are trying to do? We were trying to build a chatbot. You already know about chatbot. Here, we are trying to build a chatbot. What is that useful for? Just like ChatGPT, you have ChatGPT, right? What happens when you give a query or question? It will give you the output. Just like that, you have a chatbot, which will take the data from clinical practice guidelines. It will take the data from clinical practical guidelines. So here, CPG is the document which contains the prescriptions for different symptoms. Then what might be the steps that the doctor has to follow? And what medicines should the patient should follow? All these things will be present in that particular description or prescription. So here, doctors need to agree with the treatment. That is a smart factory in which, again, you will look at the AI, which is artificial intelligence. You have a lot of other things present. What did we discuss up to now? So artificial intelligence, we want to build applications on this particular platform. So for that, you have examples given. One is AI preventive maintenance, that is AI predictive maintenance. And what is the third one? That is smart factory. Apart from these, again, you have a lot more. What are those? The next one that we have is AI supply chain. If you look at this, see here, if you look at this, there are a lot of components present. All of these components are not manufactured in the same location. They are manufactured from different locations. So here what we are trying to do, we are trying to forecast how those components each of the companies have to manufacture. In this particular project of supply chain management, we are forecasting how those components each of the companies have to manufacture. And you should be in a position to predict whether there is any delay in the project or not. And what time you need to transport your engine. All these things you have to predict according to this data, which is supply chain. And also, we will see the next example before moving on to that. This is one more example of supply chain. See here, what is there? So here, imagine what like Amazon, there is an Amazon, right? Amazon comes up with a predictive analytics. What is it? It comes up with predictive analytics Now, what are the components that we have to place? For example, for example, what? You want to purchase a shirt. I want to purchase a shirt. So I will place an order. So whatever my requirement is, I will place an order. After that, Amazon, what it does is, it will send the message to the nearest inventory if the item that I have ordered is available in the inventory or not. If it is available, it will be shipped and delivered. What if the item is not available in the inventory? So it is there in the inventory, which is far away, that is not nearby. So it will be delivered a bit late. So Amazon started predicting what are the products that people in the region might place an order for. It started predicting the people's mind, people what they are going to order. All those things it is going to predict so that the products will be maintained in the inventory beforehand. This is called as anticipatory package shipping. What is it called as? This is called as anticipatory package shipping. We are predicting whether a person is going to order this product or that product. Based on that, I will make them available in the inventory. So this is one more example for supply chain present. And also what else? What else? So this is, here you can see the name of this. That is anticipatory package shipping. You can see here at the top. This one. Now, you have given an use case in this particular sheet. So what is the use case? Artificial intelligence use case. What is this use case? So, what are these things? Okay. So here, we have done, during the COVID times, what we have done, it is all about facial recognition. Nobody wants to touch anybody, right? So it's all about facial recognition. And what happens here? There will be CCTV cameras present. So there are CCTV cams, and then it will track you and automatically recognize that you are the employee and open the gates. Okay? Automatically authorized entry is provided if you are employee of the company. Not just that, once we have the video also. I will take the video in bit format. To avoid the data privacy norms, I will take that in bit format. By converting the video into bit format, you don't worry about data privacy, and data is shared as a report. You can see it here. So see, I will convert this into video. Video is, I'm converting it into bits. I'm storing it into cloud, and I will find the AI solution, and that will be shared in the form of a report. So this is an example provided, which is a use case. So out of 10 people who did not come out of the exit, you exactly know how those, who those 10 people are. Why? Because you are observing the CCTV footage of every people based on the facial recognition. That is the one thing present, that is the use case. So artificial intelligence solution, identify the employee and automatically record the name, gender, employee ID, in time, out time, camera IP address, behavior of the employee. So basically what we do is, we will just observe from the CCTV footage or CCTV camera that what is the person's details and whether he's an employee or not, what is his ID, whether he's in time and out time is correct. You will observe all these things, but in addition with that, you have to observe the behavior of the employees as well. Whether he's sad or happy or angry, all those things you need to understand. And cloud-based solutions can be easily deployed and on-premises based on need and can easily integrate with existing infrastructure. So these are the things that you have to make a note of. You have to remember these things. Let us move on to the next thing, present. So there is another use case given. Another example is, suppose you enter a retail store. So the girl is having the app retailer. Okay. This is another example. This is fine. Now this is one interesting example. See here. So there is a girl who entered into a retail store. Now, what happens in the moment she enters the retail store? it automatically do the synchronization. What is that synchronization? So if you have added 20 items in your cart, if you have added 20 items in your cart, what happens? She had, see here, she had an app on her mobile, which is retailer app. So the IB com detects Jesse in the shop. So once it identifies that person, it automatically sync that particular shopping list to that particular location. So here you have a location sensor data. Based on that, it will give you the directions of where to find that product that you want. So Jessie picks up the smart cart and she goes to the aisle. The tablet or the cart shows her the relevant information about the products on using the location sensor. And after that, what it she will pick up the products that she want from the smart shelf into her cart, though back an application for shelf replenishment and management. What is this one? So when I just have, for suppose I have a smart shelf within which I have 20 shampoos. So when I am using the location app in order to locate wherever my product is present, I'm taking one shampoo from the shelf. So this information will automatically get updated in the background. So the staff will maintain the shelf replenishment and management gets updated real time. This is what happens when you have this particular artificial intelligence related applications. And what she is in cooking section and picks up the spice. Table on cart displays few recipes that use that spice. This all comes under AI. She comes across smart display. It has distance sensors and face recognition to identify whether she is a female or a male. She is interested. All these things comes under artificial intelligence applications. This is what we have in this module. So let's have a quick 10-minute break and we will get back and move on to the next topic. What is that? Okay, everybody, let's get back. So what did we discuss up to now? We have seen what is the concept of deep learning concepts, why they are learning those to build AI applications, and some of the examples of those AI applications which we have seen. Now let's see what is present in the next slide. So the next one that we have is machine learning primer. So we will have a quick intro of this. First, you have to understand, what you have to understand is that we have data. What is it? We have data which is in raw format. From that data, we need to get information. From that information, we need to get knowledge. Everything is present here, see? So that is machine learning. What is machine learning here? So traditional programming versus machine learning. So here you have data, that from that data, you need to get the information. And from that information, you need to get knowledge. And from knowledge, you need to get wisdom. These are the various levels of abstraction that you need to traverse. So, and what is the difference between traditional programming and machine learning? What is the difference? So we have already talked about traditional programming and we have also seen machine learning. What is the difference? In traditional programming, what we do is we take the data and we write a program to ensure that we get the output. So we write the program on the input data that we have and we will get the output. That is traditional programming. But what happens in machine learning? Machine learning, you will take the data as well as output together. And you supply the data and output to the computer and you will get the program as output. So see here, it is present here at the bottom. So that is the traditional programming. You will have data, you will write the program to get the output. And in machine learning, what happens? You will take data and output together and you will supply it to the computer and you will get the program. This program is nothing but the equation or the patterns between your data. So in supervised and unsupervised, we have talked about why we are dealing with those. In order to understand the patterns in your data, to make the predictions, we have to understand the patterns. All those things or the mathematical equation that we have seen, that comes under program here. That is nothing but program here. Now what? So, okay, let me clear these things. Now, what is it? What do you mean by equations? We have already discussed about equations. Like in linear regression, we have talked about regression. You will have an equation like y is equals to beta naught plus beta 1 into x1 plus beta 2 into x2 and so on, depending upon your number of input variables. But coming to here, this neural networks which we are about to discuss, there also you have an expression like y is equals to b plus, y is equals to b plus w1 into x1 plus w2 into x2 and so on. So we will talk about this equation clearly in the next in the coming session. But right now, this is nothing but the program or equation or the patterns, anything is fine. Now, after that, you have the different types of machine learning. We have already seen this. What are the different types of machine learning? One is supervised learning and second one is unsupervised learning. So what happens in supervised learning? See here. In supervised learning, you have an input variable as well as an output variable. And here, if we predict a categorical class, that is called as classification. If you are predicting a numerical value, that is called as regression. So you have talked before linear regression. So what is this linear regression? In linear regression, when do we use this? When my output is continuous. So when it is numeric data, what is it called? It is called as regression. And when coming it to the logistic regression, we will use logistic when we have the output variable as categorical. When we are predicting a categorical class, that is called as a classification problem. So these are the two things that you have to remember. And coming to the next one, you also have a lot of different things. If you are searching for a movie from a large pool of movies, then that is called as recommendation. And then we also have the next one, that is retrieval. When you predicted the relevance of an entity to the query, that is called as retrieval. This comes under supervised learning. Supervised learning will have an input variable as well as an output variable. If you are predicting a numerical value or numerical class or values, it is called as a regression. If you are predicting a categorical class, it is called as classification. From a different pool of options, if you are predicting one option according to the user preference, that is called recommendation. If you are predicting the relevance, that is called as retrieval. That is about supervised learning, which is one type of machine learning. And the second one that we have is unsupervised learning. So what is this unsupervised learning? In this, you don't have an output variable. See what is there here. Okay, here there is not much that is provided here. You already know about unsupervised learning. In this, you don't have output variable. Output variable is unknown. Along with that, you have semi-supervised learning. What is semi-supervised learning? Semi-supervised is nothing but it is a mix of supervised and unsupervised. How one way to look at it is the moment you get the data set, you can apply probably clustering to it. You have a data set. Now, probably I will apply clustering. Clustering comes under what? Unsupervised learning. Once you do the clustering, you will get individual different clusters depending upon the similar data types or similar data points. Now, if you have million records, 1, 2, and so on, there are million records present, and you are about to do the clustering for this, then you will get very small, sizable clusters. Okay? Once you get these clusters, each and every cluster, you will perform the predictive modeling techniques, which is supervised. You will apply different algorithms depending upon your choice, whether it is decision tree or naive Bayes, anything is fine. Now, this is how we can call it as semi-supervised. It is a mix of supervised and unsupervised. We are doing the clustering and we're also applying the predictive modeling. This is semi-supervised learning. You have to keep this in mind. And what else? What else are there? Semi-supervised, that is a mix of supervised and unsupervised. And you have the next one, that is active learning, transfer learning, and structured prediction. What is this one? What is this one? This is nothing but we are making or we are using the pre-trained models. We are using the pre-trained models. What do you mean by pre-trained models? How can we understand this one? So there are a lot of pre-trained models that we are working on deep learning or neural networks. So to train your deep learning algorithm, you need a lot of data. So there is a deep learning algorithm which deals with complexity of data, right? Complex data. In order to just train this algorithm, you need a lot of data. You need to have a lot, like access to a lot of data. So we need very powerful computers. The more the number of parameters, better would be the learning in machine learning algorithms. So you already know beta naught, beta 1, all these are parameters or coefficients. The more the number of parameters, the more would be the learning in machine learning algorithms. When it comes to regression algorithm, as I talked about before, y is equals to beta naught plus beta 1 into x1 plus beta 2 into x2 and so on. These are all the parameters. Here, all the data values are called as parameters. When you have the algorithm, it will understand the pattern, and those patterns are actually getting captured using these coefficient values. These are called as parameters. But when it comes to neural networks, which we are about to talk, when it comes to neural network, you have an equation like what? Y is equals to b plus w1 into x1, w2 into x2 and so on. These are all the parameters here. So the more the number of parameters, the better would be the learning. So say there is an algorithm which is built on cats and dogs. Say there is an algorithm which is built on cats and dogs. So there is an image or machine learning or deep learning algorithm was built on that. And whenever you supply a new image, that new image will be classified either as a cat or a dog. Now, if I were to take this algorithm and we use the same algorithm on cancer, can we use the same thing? I will take the same images and I will apply the same algorithm that I have used for this classification. Can I use this for some other purpose also? Yes, I can use it. That is called as a pre-trained model. That is called as a pre-trained model, which is nothing but transfer learning. The knowledge that I got from one particular case is used or transferred to another one, which is called as transfer learning. And what is structured prediction? Structured prediction means whenever we have a sequence of words, you can use this structured prediction. This is about the machine learning types, that is supervised, unsupervised, semi-supervised, reinforcement learning, and transfer learning, and also structured prediction. These are the things present, and what else? Let's see what else are there. So you have to learn the terminologies over here. What are the different names that we give for output variable? That is response or dependent, regression, explained variable, criterion, measure variable, experimental variable, label, and outcome, so on. And if you have input variables, those are also having different names like explanatory, predictor, independent, covariates, regressors, factors, control variable, exposure variable, input variable, and so on. These terminologies you have to remember. Now coming to the next term, which is memory check. So, does this pathology whole slide image show cancer? So what is this thing? See here. So, is this a classification problem or a regression problem or a recommendation problem or a retrieval problem? We have to understand. What is it? So we have to understand whether the question given here is a regression problem or is it a classification problem or is it a recommendation problem or is it a retrieval problem? These things we have to categorize here. So does this pathology slide image show cancer? What is this one? This is categorical data, not numerical. When it is categorical, then what is it called? It is called as classification problem. It is called as classification problem. Then what is the next question? What will this stock value be tomorrow? Value is number. Number is nothing but regression. So this is regression problem. And what else? Sorry. So what is the next question? How much interest rate should I lend money to customer X for? So money, interest, everything is a number. So number is nothing but what again? That is a regression problem. Numbers comes under regression problems. Categories comes under classification problem. When you have pool of options, when we are preferring one user, based on user preference, that is called recommendation problem. So is employee X about to treat? Is employee X about to treat? So he is treat or not treat? What do you mean by that? That is a two-class classification problem, whether he is treating or not. That is two-class classification problem. Why classification problem? Because this is a categorical data. That is a two-class classification. And what is the next question? What activity if user doing in a video? Is he stealing or is he shopping? There are again two classes. This is also a two-class classification problem. Because this is categories. This is not based on numbers. And what else? What objects, man, woman, animal, are present in the image? An image may be anything. So this is multi-class classification. This is not a number. This is category. This is multi-class classification. And what else? How many MacBook Pro I sell in New York next year? How many, which means a number, which means regression problem. Is this a positive or a negative tweet? So that is category and it is having two classes, positive or negative. So that is a two-class classification problem. Which song are you humming the tune of? What is this one? Which song are you humming the tune of? That is a retrieval problem. How high the value of land go in a decade? That is number regression problem. Who will be the best match for you out of all those? All these things are the problems that we have to classify it into either regression or it is a classification, or it is a recommendation, or it is a retrieval. So you have to understand these things properly. And what else? What else are there? So the next thing that we have is deep learning history and applications. So let's see the history and applications. What are there? Let's move on to the first slide. That is deep learning history. So until 2012, if you see here, 2012, there was a tug of war between SVM and neural networks. So you are not familiar about all these things, but fine. I won't explain you this. So there is a tug of war that is happening between SVM and NN. These are falling under the category called as black box techniques. You may have heard this word before, but you may not familiar with the concepts. So that is a concept called as black box techniques, which you have SVM and neural networks, in which we are about to discuss neural networks. So people were trying to manually extract the features when it comes to images. When it comes to images, they want to manually extract the features. So how this is happening? How we can manually extract the features? You have an image will automatically will have the pixel intensity value. Based on that pixel intensity value, if you have an image, that image will have pixels. Each pixel will have intensity value, and each intensity value will ranges from 0 to 255. So you have an image given, and image data, if you want to work with image, text, all this complex data, we will go for deep learning concepts. And here, each image will have a pixel, and each pixel will have intensity value. That intensity value ranges between 0 to 255. If it is 0, it means black color. If it is 255, that is white color. If you can manually extract this information and place it in a tabular format, if you manually extract these features and place it in a tabular format, for each image, if I say I have 6 into 6 matrix. So if I have 30, so I have totally 36 features. Now, on this data set, I want to apply the predictive model techniques. You will have an output variable, which is happen to be a label. That this is, maybe this image is tiger, or it is a mushroom, or a cherry, or a leopard, or whatever it is, it will categorize. It will categorize. If you take this data and supply it to a predictive modeling technique such as support vector machine SVM, it will give you an output which will classify and deliver the result. So you can see the images present here. When I provide these images to this particular algorithm, which comes under black box technique, it will categorize or classify my data and gives me the result, whether that image belongs to leopard or motor scooter or container ship or mite or mushroom or cherry, whatever it is. It will classify and deliver the results. But when it comes to neural network, so when it comes to neural network, what happens in neural network? So when it comes to SVM, it will classify and deliver the result. But when it comes to neural network, we have to, however, when you have to use neural network, what happens? These kind of features regarding any file, it will be automatically extracted. So SVM will manually extract the features, whereas neural networks will automatically extract. If you are automatically extracting the features, the disadvantage is that what features your model is extracting, you could not know anything. You don't know what features are extracted. This is the disadvantage, but this is faster. Okay, back in 2012, algorithms are given like 70 to 75% of accuracy. You can see it here. So back in this 2012 year, it was like the algorithm is giving, the normal algorithms are giving 70 to 75% of accuracy. In terms of image detection, it is giving it. So detecting what is there in the image, that is the task. Whether it is which type of image, whether it is a leopard, whatever it is, we are classifying it. It is a very big task. So it is giving approximately 70 to 75% of accuracy. But when people tried out neural networks, the deep learning neural networks, this algorithm, they have achieved an accuracy of around 85%. From then onwards, it is all about neural network algorithms. So this is the architecture of a neural network algorithm. See here. So this is the architecture. So way back in 2015, this was considered as a problem. So artificial intelligence is used back then, and today it is even more matured. What is AI in the first place? If you can automate, so see here, these are the things that you have to remember. So by using the network or neural networks, he achieved more than 15% accuracy. Okay. So here, these are the things that you have to remember. Method used and what is the error rate and human performance. So these are the things that you have. And coming to here, what is the artificial intelligence in the first place? If you can automate the human intelligence, if you can automate the human intelligence, and if you can help achieve performance that is artificial performance, and humans achieved an error rate of 3 to 5%. Given this context, AI has surpassed that. So this is what you have in the history of deep learning. Now, let's check out what is present in the next slide. So the next one that we have is deep learning applications. So there are a few applications provided here for you in order to understand this deep learning concept. So this is useful in speech recognition. So Microsoft researchers achieves new conversational speech recognition milestone by using this deep learning concept. And also see here, this is the error rate that was provided here. And then you have this alternate breakout, one more example. And this is one easy example provided here based on an image. Here using the deep learning concepts, I have to just understand, I have to give a caption for the image. This is nothing but image captioning. We are about to provide a caption for every image by using these deep learning concepts. So by looking at this image given, what you can understand, two pizzas are sitting on top of a stove, two pizzas sitting on top of stove top oven. So what happens in artificial intelligence driven applications is you can use it for multiple purposes. So you can use it for chatbot, you can use it for colorization, you can use it for captioning, everything. There are a lot of different concepts present. And what else? Image caption, see what is this image? A group of people shopping at an outdoor market. So it is very tough for us to understand that this is a market and there are a lot of people, they are shopping within the market. These are very hard for us to understand using traditional algorithms. So for this complex data, I have deep learning concepts. And what? So here, if you see here, this is a chat bot which is based on AI deep learning concepts. So what happens in this AI driven chatbot? So here it is an image given to the chatbot. And if we start asking questions and the chatbot would start responding. So see, a man and woman are holding umbrellas. I ask the question, what color is his umbrella? He is just understanding what color is this? This is black. So he is giving the answer as black. So what about hers? So not only he is understanding the color of the image, but also the terms that we are using. Her means woman, his means man. So man carrying an umbrella, what is the color of it? Woman carrying the umbrella, what is the color of it? Based on that, your chatbot is responding. Based on that, it is responding. So we have something called as ANN, which means what? That is artificial neural network. It is also called as dense network. Dense network, this is basically used when you have structured data. When you have structured data, or I can also call it as tabular data, or I can also call it as columnar data. When I have such data, I can go for the type of neural networks that is artificial neural networks or dense networks. Then we also have something called as CNN. CNN stands for convolutional neural network. Convolutional neural network. So this deals with images. This deals with images. And then you have the next neural network that is RNN. RNN stands for recurrent neural network. And this deals with textual data. This deals with textual data. So these are the namings present that you have to keep an idea about. So artificial neural network is there. It is also called as dense network. It is preferred when you have structured data. Structured data means columnar data or tabular data. So when you have images, you will prefer CNN, which is convolutional neural network. When you have textual data, you will prefer RNN, which is recurrent neural network. So these are the various things present that you have to concentrate on. So let's move on to the next one. This is the chatbot, RNN generated speech, as well as you have the speeches. And as I told before, you have the next concept, that is deep colorization. So you will have a lot of images in black and white. If you take those images and if you supply those images to the deep learning model will automatically put a color to these images. That is called as deep colorization. See here. So there you may have a lot of black and white pictures like this in your gallery. So when I just provide these images to these deep learning concepts, it will do the concept called as deep colorization, which means it will add color to your black and white. So deep learning is present everywhere. There are a bunch of additional applications also given. You can understand everything clearly. So what did we discuss? Artificial intelligence to build these applications. I have the concept called as deep learning. In deep learning, you have SVM and NN, in which we will talk about neural networks. In neural networks, again, we have different types. ANN, artificial neural network, CNN, convolutional neural network, and RNN, that is recurrent neural network. We will see each of these things clearly. This is used when we have image data. This is used when you have textual data. This is preferred when you have tabular data. Depending upon the type of data, you can go for different types of methods. And as we told before, this is useful when you have complex data. When you feel like the traditional algorithms is not giving you the better results, you can shift to the deep learning algorithms. Okay, these are the various things that we have seen, and there are a lot of different applications like we can build a chatbot. It will give me the answer. I can also build I can also work it for colorization. And there are a lot of other things. I can use it for image captioning. All of this comes under the applications of deep learning. And what is present next? So deep learning is everywhere. So see here, internet and cloud for medicine and biology, for media and entertainment, for security and defense, for autonomous machines, everywhere we are using these AI or deep learning concepts. So you can check it out, all these things. Internet and cloud, we are using for image classification, for recognizing the speech, for translating the language, for processing the language, for analyzing the sentiments and recommendations. Coming to the medicine, the cancer cell detection, diametric grading, drug discovery, and video captioning, which we have seen before, search of a video, and real-time translation, detecting the face, surveillance of videos, imagery, satellites, pedestrian detection, recognize traffic sign. All these things are some of the applications of deep learning concepts. And what else? So there is the next one, deep learning use case. You can see here general use case and which industry it belongs to. So sentiment analysis, CRM, social media, augment search, threat detection, fraud detection, all these things you can go through. Study hard so that you can master technology, which allows us to master nature. So these are the things present in this module. So what did we discuss in this particular module? What did we discuss? We have started discussing about the basics of deep learning and AI. So we have further other modules also for deep learning. We will see everything clearly, and also we will work on these things in the RapidMiner studio as well. So before moving on to the next module, let's go and check out what is present in the mind map. So what did we discuss? We are talking about a specific methodology, that is CRISP MLQ methodology, in which you have a lot of stages, out of which the first one is business understanding and data understanding, and the second one is data preparation, and the third one is building a model building, and fourth one is evaluation and deploying a model. All these things we have, out of which in model building you have the black box techniques. Let's check it out what is there in that. So model building, we are currently in this one. So in model building, we have a lot of different things. Check it out. What is that? Supervised is there. Predictive, we have again 3 types. Shallow, we have already seen this. Regression, we have talked about this. The next one that we have is black box techniques. So black box techniques, I told you that is support vector machine and neural networks, out of which we are going to talk about neural networks. So in this, you have a lot of different things, CNN, RNN, LSTN, and what are various encoders. All these things we will learn in neural networks. Okay, these are the things that we are about to discuss. Let's see the next module of slides, what we have. So in this particular module, we are about to cover the concepts of human brain, what is the compositionality in the data, what is perceptron algorithm, what is training perceptron algorithm, what is artificial neuron, what is handling non-linear patterns and multi-layer perceptron, activation function, and what is error surface, what is back propagation algorithm, what is weight calculation. All these things we will discuss in this particular module. So why we got human brain here? Why we are talking about the compositionality in the data? We will see all of these things clearly. First, how can we mimic the human brain? So the biological system, in the biological system, you have the human brain. So people started exploring that and amazed with the kind of grasping we all have. Like the IQ level is different for every person, but still there is grasping power present in every human brain. So people thought, why not? I will use those. People's or humans have a lot of neurons, and all those neurons are interconnected with each other. So can we take those and can we put those in the artificial system? And in a minute, the artificial human brain or biological brain I got, which is coming under the machine learning algorithms. So this is the human brain. Why we are talking about is because the word neurons is there, which are interconnected with each other. Because of the grasping power, if we apply to that artificial human system or biological brain, that comes under the biological system. So this is, see, that is, if I apply the biological system brain to the artificial system, then what happens? That is nothing but how can we mimic this human brain? So see here, the basic unit of information processing is called neuron. And how many number of neurons are there? That is 10 power 11. 10 power 11 neurons are there. On an average, the number of connections per neuron is 10 cube 1000 or 10,000. Average number of connections are there per neuron. And the communication speed is very slow, order of a few milliseconds. And complex perceptual decisions take just a few 100 milliseconds. Perceptual decisions means when we are working on multiple things at the same time. It will just take 100 million seconds for each work. And there's this 100-step rule. Any perceptual task may not be passing through more than 100 neurons. So that those are the basic things that you can go through. The next thing that we have is why has use of multiple layers to success DL. So here see, it captures compositionality. Word is compositional. When it comes to, see here, when it comes to recognition an image, as a human, you will first go and observe the pixels in the image. Then what is the edge? What is the textron? Or what is texton? What is motif? What is part and what is object? Each and every part is having again the sub objects or sub parts. You will understand all these things when it comes to image recognition. When it comes to text, what is the character? What is the word? What is the word group? What is the clause? What is the sentence? And what is the story? And in speech, what is the sample? What is the spectral band, sound, phone, All these things are the different levels that we are going to understand, which is nothing but compositionality. So exploiting compositionality gives an exponential gain in representational power. So what is that? We will see. So see here. This is what I want to tell you, compositionality in this data. So here you have a lot of images given. What is this? These are the lot of images that you have been given to this algorithm. So when you are providing images, what happens to this? In the first, you supply all these images to the layer called as input layer. What is it? Images are there. I will supply these images to the layer called as input layer. And what happens here? This first layer that you will get here is the input layer. Check it out. So this is called as input layer. So images are there. These images are sent to the first layer, that is input layer here. This is called as input layer. And then initially the hidden layers will capture. What is hidden layers? You can see it here. So see here, these are the hidden layers present. What are those? These are the hidden layers present. So what is the use of this hidden layers? What is the use of this hidden layers? So in the first, we will supply all the images to the input layer, which is the first layer. The hidden layer will capture the low level features. The low level features are getting captured by the layer called as hidden layer. For example, a face to face. For example, there is a face. In a face, there is a face present. In this face, what happens? First, I will send this image of face to the input layer. So input layer, after that you have hidden layer. Hidden layer, it will capture low level features. What do you mean by low level features? Which means it will understand what is the pixel, what is the edge. All these things are present. And after that, the information is getting captured in the hidden layer. Then the next hidden layer, it will capture mid-level features. And mid-level features is nothing but what is the eye, what is nose, what is mouth of the person, etc. All these things are mid-level features. Then you have the high-level features, which is nothing but your entire face. So this is what happens here, which is the level-wise in compositionality. See here. So mid-level features, low-level features are there. And after that, again, one more hidden layer, it will capture the mid-level features, which is this one, like a person knows all these things are present. After that, it will give you the entire image, which is the face of the person. This is called as the concept called as compositionality. So high-level feature is nothing but face, of course. These are the final set of hidden layers. So you can have as many hidden layers as you want, but you can have as many hidden layers as you want and as many neurons as you want in each of the hidden layer, which captures the features at last, which will give you the output layer. This is the output layer. So you have to remember the namings here. These are the images that we have provided. And after that, we will send it to the input layer. After that, you can have as many hidden layers as you want, which captures the features. And finally, it will give you the output layer. The output is nothing but the face. Now what else? Now what else? When it comes to vision related problems, when it comes to vision related problems, what you do? You will manually extract the features. After that, you can use the prediction algorithms. When it comes to speech, you can use the same thing. You will manually extract the features and apply the supervised or unsupervised machine learning algorithms. So if you have shallow models, you want to apply traditional machine learning models or traditional machine learning algorithms. You have to manually or handcraft your features. You can apply a classification technique, some kind of traditional models. Then if you apply deep learning model, you can automatically extract the features. There is no need to manually extract it. This is called as representation. You have to check it out here. So there is vision related problems. If I go for this, you have different techniques present in order to extract the features. And you will supply it to the machine learning algorithms, any one of it of your choice. And when it comes to speech, Again, there are different methods and different algorithms. And when it comes to textual data, again, different methods are there and different algorithms are there. Okay. And when it comes to shallow models is nothing but the traditional machine learning algorithms. We will handcraft the features. This is what we have. When we apply deep learning or deep models, they are automatically extracted. That is a classification problem, which is called as a representation. So these are the things present, which are the basics that you have to understand. Now, what is the next thing present? So coming to the mathematical notation, we will talk about this mathematical notation after a quick 10-minute break. So we will have a quick 10-minute break and we will get back and discuss about this. Okay, everybody, let's continue with the session. So we are currently talking about the mathematical notation recap. So what is it? So what does it see here? This is the mathematical notation that you have. Okay, before going into that, we will see, suppose you have a data set which have inputs. You have a data set which is having inputs. Here, if you have maybe 5 inputs, imagine you have 5 inputs. So you will have here 5 neurons. We are talking about neurons, which is neural network. So how many neurons it is having based on your inputs? If you are having 5 inputs, you will have 5 neurons in the input layer. So the first layer is input layer and the last is output and middle are called as hidden layers. In the input layers, how many number of neurons will be there? Depending upon your inputs. If I have 5 inputs, in my input layer, I will have 5 neurons. Now, and additionally, you will have one more neuron that is biased. We will talk about that later. So for suppose, imagine there are 2 classes. 2 classes data points are there. One is pink class, another one is blue class. So there are 2 classes. Now, if I like all the regions or all the blue color belongs to one class and all the pink color belongs to another class. And if I draw a line in between, what is it? If I draw a line in between, so what is the equation of a straight line? That is y is equals to b plus mx or c plus mx, and anything is fine. You can draw one median line between, which will segment the 2 classes. So what is the equation of the line? If you look at your linear regression, you will have this equation. What is the linear regression equation? Y is equals to beta naught plus beta 1 into x. What is this one? This is y-intercept and this is slope. Here also the same thing. On the similar line, when it comes to neural network, algorithm or neural network, anything is fine. You have the equation that is y is equal to b plus w1 into x, where b is the intercept and w1 is the weight, or b is the bias and w1 is the weight. All these multiple, like if I multiply these things with 1, if you observe b is 1 and beta naught is also multiplied by 1 and this is also multiplied by 1. So if you have j inputs, if you have j inputs or 5 inputs, okay, instead of taking number, I will take 5. If I have 5 inputs, now what will be the equation for the neural network? What will be the equation? Y is equals to b plus w1 into x1, which is bias and weight, and w2 into x2, and w3 into x3 plus w4 into x4 plus w5 into x5. Why? Because I have 5 inputs. All these put together called as weights. So all these weights are randomly initialized. You have to remember this thing, which is the most important. So all the weights are randomly initialized. All these neurons are connected to other neurons. You will see it here, see here. So when you look at this, if I have 5 inputs, I got 5 inputs. Now, how many neurons you will have in the input layer? That is 5 neurons, 1, 2, 3, 4, and 5. And in addition to the 5 neurons, you will have one more neuron in which there is no bias. So that is basically bias. It is talking about bias. Remaining everything is weight. And what else we have talked about? What else? So you also have the like a statement called as weights. Weights are randomly initialized, and all these neurons are connected to one another. All these neurons are connected to one another. See here. After that, what you have the next component, that is called as integration component. So this component is there. This is called as integration component. Integration component is there, and you have another one which is activation component. Integration component and activation component. So integration component, here we are basically taking the function summation. Here we are taking the step function. But usually integration function is summation. here, that is why we are adding all the weights together in the equation, like b plus w1 into x1. We are doing this because basically the integration component is having summation. And when it comes to the next one, that is the next one, activation function. What do you have? You have a step function present here. What is step function? What is the step function? So this integration value that you got here will be given as input to this activation function. Here the example given is a step function. What does the step function do? It will take the input and gives the output. If you have an integration value as 0, if the integration value that I got 0, then if I pass through the step function, it will give me the output 1. If you have the integration value which is greater than 0, then again it will give me the 1. If the integration, the summation value is less than 0, then it will give the output as 0. So you have to remember one thing, that is f of x, which is this function output. If it is greater than or equal to 0, then the default value is 1. If x is less than 0, then the non-default value is 0. This is what we have to remember. As we talked about before, the value is 0.8, which means it is greater than 0. For suppose, if I have found the value after finding all those things for my input values as 0.8, then what does that mean? 0.8 means obviously it is greater than 0. So the output for the activation function is 1. That is your predicted value. That is how you will do when it comes to neural networks. Suppose you have 1,000 observations. Suppose you have 1,000 observations. The moment you pass these observations through your neural network, say you have the actual value of the first record, 1, 2, just like that, I have 1,000 records. And I am passing these records individually one by one into my neural network. So what happens? I will just get the predicted value. So there is an actual value here and there is a predicted value that I'll get. So say you have the actual value of the first record that the person will not default. The actual value is the person will not default. And I got the predicted value. What is the predicted value? I got the predicted value like the person will default. Now what? Now what? If you are getting like that, the predicted value and the actual value are not matching, then you will get an error. And that equation is called as loss function or cost function. In that way, you will pass all the observations to the neural network. And after that, you will get an individual value. If there is no match, if the match is not found, if both are having DD, then what? It will have no loss. If it is not matching, you will have some loss. So these are calculated for all the observations present in your data. And after the cost losses you got, that aggregation is called as loss function or cost function. The aggregation of the total loss value is called as loss function or cost function. And when you take that loss function or cost function, your objective, the main objective of yours is you have to minimize the loss function. The main important objective of yours is you have to minimize the loss function. So going forward and coming backward, what is the objective? That is to minimize it. How can we minimize it? And what is this called? This is called as back propagation algorithm. This is called as back propagation algorithm. Why we are doing this? Why we are coming backwards once the process is done? In order to update the weights. In order to update the weights. Why do I have to update the weights? To get the minimum loss. This is the process of going forward and moving backwards, the back propagation algorithm. We have to update the weights so that the minimization of loss will happen, which will be our main objective. This is the back propagation algorithm. Okay, so let me remove it and show it to you what is present in this slide. Okay, before talking about all these things, we will see what are the different neural networks present. Okay, so here, what did we talk about up to now? We have talked about the process. First, whenever we are applying the neural network, the data is passed into the input layer. And after that, it will give you a lot of hidden layers in which it will draw the mid-level features, the low-level features, and finally, it will give you the output. This is what we have discussed up to now. Suppose the weights are randomly initialized. As we talked about before, the weights are randomly initialized. If certain weights, in certain weights, if you will have some lost value. So what did I talk about? When I update the weights, when I do the back propagation algorithm, I can just achieve my objective. This loss function will get reduced using the algorithm called as gradient descent algorithm. Using the algorithm called as gradient descent algorithm. Gradient is nothing but rate of change. So whatever that we have the objective in reducing the loss function, that is applied with the help of an algorithm called as gradient descent algorithm. And you have few more variants here in gradient descent algorithm. One is batch gradient descent algorithm. One is batch gradient descent algorithm. What happens here? What happens here? For suppose if you have 1,000 observations and if you pass all these to your algorithm neural network, you will get 1,000 different loss values as we talked before. When you combine all these together, when you get aggregated value and when you back propagate in order to update the weights, when you update the weights in such a way that the loss function or cost function is minimized, the minimization happens using gradient descent algorithm. In this batch gradient descent algorithm, you will notice two different words. One is iterations and second one is epoch. So what do you mean by this iteration and what do you mean by epoch? So in this batch gradient descent algorithm, you have these two concepts. Epoch means you will pass all of your data points to the neural network one time. That is called one epoch. All data points to the neural network algorithm one time. That is one epoch. So when you aggregate all of those things, you will get the cost function. When you back propagate, when you use back propagation algorithm, you will just update the weights to minimize the cost. Each time you are updating the weight, it is called as iteration. What is it? Each time you are passing all data points through the algorithm once is called as one epoch. And what do you mean by iteration? Each time you back propagate and update the weights is called as one iteration. Now let's see for each and every individual method present, how many iterations are happening for one epoch. Okay, let's check it out. So we are talking about the gradient descent algorithm. Gradient is nothing but rate of change. In gradient, we are talking about the batch gradient. Batch gradient. So in batch gradient, for one epoch, how many iterations are there? So what happened in batch? We are taking the entire data and passing it to this algorithm of neural network, and you will get the lot of costs in which you will get the aggregation value and you will back propagate and update the weights. So for one particular epoch, one time all the data points passing through the algorithm, there will be only one iteration because only one back propagation happens. This is what happens in batch gradient descent algorithm. And again, you have the second one, that is SGD. The second one you have is SGD, stochastic gradient descent. Stochastic gradient descent algorithm. This means random. So in this, what we have to do is, we will randomly choose the observations. So there are 1,000. So first what I do, I will choose the 7th record and I will pass. I will choose second record, I will pass. I will choose fifth record, I will pass. I will randomly choose the observations and run it through the neural network algorithm. Then I will get the loss and I will get the aggregation cost, and I will just do this for randomly selected observations. So each time you are updating the weight, it is called as one iteration. So for one epoch, once all the data points are passed, you will have 1,000 iterations, because every time when I pass first record, I will get back propagate, another record, random record, back propagate. So for one epoch, for once all the data points passing through the algorithm, I will have the number of observations of iterations, that is 1,000. That is the second one, that is stochastic gradient descent algorithm. And coming to the third one that we have is mini batch gradient descent algorithm. So here what happens? So you need not to send all the observations. Here you have to define a batch size. Say I have taken for 1,000 observations, my batch size is 200. So how many batches will I get? I will get 5 batches, one with 200, one with 200, and so on. In batch 1, this is mini batch stochastic gradient descent. Stochastic means we will randomly select the variable, and mini batch means we will have a batch size. In batch 1, I will randomly select the observation and I will pass it through the neural network. I will get the cost and so on. I will do the same thing for different values. So what happens here? This goes on for all the batches. So for one epoch, for all the data points, I will get 5 iterations for 5 batches, depending upon your batch size. So these are the things that you have to notice when you talk about iterations and epoch. Okay, now let's see what is present in the further slides. These are the things that you don't need to understand. The basic thing is enough for you to work on the RapidMiner Studio. Basic idea is we have to update the weights. This is the toy example. You can go through all these things, activation functions, what are the hidden layers present, how many hidden layers are there, and what insights that we can get from the activation functions, what are the different functions that we have, everything that we can go through all these things. So before moving on to the error surface, I want to talk about a few more things. So what kind of decisions or what kind of decision boundaries do MLPs learn? So up to now, what did we learn? How many neurons will be there in the input layer? If I have 4 inputs, then I will have 4 neurons in the input layer plus 1 bias. So the number of neurons in the input layer are pretty much defined. Then when we have hidden layers, the number of layers in the hidden layers will depend upon you, which means whatever the method that you are choosing, whether it is batch gradient descent, mini batch stochastic gradient descent, or stochastic gradient descent, whatever the method that you are choosing, depending upon the method, your hidden layers will be there. So the number of hidden layers and the number of neurons in the hidden layers and any activation function, all these are called as hyperparameters. So what is this? The number of neurons and the number of, or what can I say, whatever the activation function that we are using, and the number of hidden layers will all call as hyperparameters. Within the output layer, how many number of neurons and the action functions are defined? If your output variable is numeric, then you will have a single neuron. You will have a single neuron, and you will have, or when it comes to the activation function, it is either linear function or identity function. You have a lot of different activation functions you can go through, but the most useful things we are talking about. When you have your output variable as numeric, then you will have one neuron and you will have, or you will use the activation function that is linear or identity. And what? When you have your output variable as categorical, which is having two classes, then you will use a single neuron and you will use the activation function that is sigmoid. And when you have the output variable categorical, but with more than two classes, then what? Then what? Suppose if you have 10 classes, then you will have 10 neurons. Depending upon your classes, you will have neurons. And the activation function that we are going to use is softmax. You have to remember these things. If each neuron is connected to every other neuron, it is called as fully connected network. If every neuron is connected with every other neuron, it is called as fully connected network, or it is also called as multi-layered perceptron. We talked about perceptron before. Multi-layered perceptron or dense network or artificial neural network. There are multiple names present for this. So when do we call it as artificial neural network or fully covered network or fully connected network or dense network or multi-layered? When do we call this? When each neuron is connected with every other neuron. And what else? The algorithm where you have forward and then backward is called as back propagation algorithm. The algorithm back propagation is used to minimize the loss function or cost function, which is called as gradient descent algorithm, in which again you have three, that is batch gradient discount, stochastic gradient discount, mini batch stochastic gradient discount. For each one of these, the iterations and epochs will change. The number of iterations that you're going to have in each epoch varies depending upon which type of the variant that you have chosen. And when it comes to mini batch, you will have an additional responsibility of batch size. If output variable is numeric, then you can use mean square error, mean absolute error, and mean error as loss function or cost function. When an output variable is numeric, you can use mean square error, mean absolute error, or mean error as a loss function or cost function. When your output variable is categorical, then you will use something called as cross entropy. When your output variable is categorical, you will use something called as cross entropy as your loss function. So as a part of decision tree, we have learned about entropy. What is entropy? Entropy is nothing but, I will write here in yellow color. So entropy is, how can I write the formula? Minus of sigma I is equals to 1 to n, probability of I, log of probability of I base 2. So we have discussed about entropy, which is impurity, from which I will get the information gain, all those things. So cross entropy is something called as a variant of entropy. It assumes the images to deal with. Say you have an actual class. It is called maybe P, suppose C. But suppose imagine you have images. What are the images I have? I have a tiger, lion, cat. I have these images present. Now I have an actual class. Maybe I will call it as P. Now, the probability I will get is I provided the image tiger here. So what happens? Tiger will be 1, remaining else will be 0. Now, I have predicted some values. So what are the probabilities? Then if your data tiger will be 1, when you build a model with this data, and when you just observe the probabilities, when you supply this tiger image to the algorithm, and when you do the prediction, what you get? You will get the probabilities. I will take some random value 0.1, 0.2, 0.3. So cross entropy will give the loss how far away your actual value is from predicted value. So the formula for cross entropy, how can I write it? Minus sigma I is equals to 1 to n, probability of I, log of qi base 2. So how many classes we have? We have 4 classes. So how can I write the cross entropy for 4 classes? So what is the formula for cross entropy? Cross entropy talks about how much far away the actual value is from predicted value. So what is cross entropy? That is a variant of entropy. Minus sigma is equals to I is equals to 1 to n pi into log of qi base 2. Now if I have 4 classes, now what is that formula? Is equals to minus p1 log 2 q1 minus p2 log 2 q2 minus p3 log 3 p3 log 2 p3 minus p4 log 2 p4 or q4. So substitute the values. You have the probabilities, right, that we have taken before. So I will write that is 1 minus 1 into log of 0.1, and this is 0, and something into 0 is 0, something into 0 is 0, something into 0 is 0. So I will get some value when I calculate this. So this number is your cross entropy or loss or cost. This is when you have your y, which is categorical. If you have 2 categories, then you will call this as binary cross entropy. If you have your output variable with 2 classes, you will call it as binary cross entropy. If you have more than 2 classes, you will call it as categorical class entropy. So these are the things that you have to remember when you are working on this particular concept called as neural networks. So let's say the next concept, error surface. Suppose if you have 2 inputs, usually cost or loss function, loss or cost function is represented with J. Okay, so suppose you have 2 inputs and cost function or loss function is represented by J. We also know that weights are randomly initialized. If your weights are first initialized here, imagine my weights are first initialized here. So weights get updated, loss gets reduced. Wait, I'm just getting updated here, updating here, updating here. So error surface is such a simple surface, and ultimately you will reach a point which is minimum. That is minimum loss, which is our objective. This is called as global cost minimum or global cost minima. This is called as global cost minima. Your error surface will not be like that because you will not have a single variable. You will have multiple variables all the time. So you won't have this kind of curve. So see here, this is an algorithm present. When we see the surface, this is looking like this. And what else? So see, this is the propagation that is having. This is the propagation that this is having. So when you look at this, so this is, see, the first weight is present here, but when we update the weights, it is just getting to the minimum point, which is minima. And this is called as global cost minima. And see here, this is the global cost minima here. So these are the weighted things present. So depending on where you are initializing the weights, depending on where you are initializing the weights here or here, depending upon that, you will reach the minimum like this. Here means you will reach here. Here means you will reach like this. So where your weights getting initialized, based on that, you will get a loss. Based on that, it will be decided where you are going to reach. The next one that we have is back propagation algorithm. So what is back propagation algorithm? What is present in back propagation algorithm? Let's check it out. So back propagation algorithm, for the ease of our understanding, what we do is, we will use the integration function and activation function. So we already discussed about this integration and activation function. Let's combine. Let's not take the bias into consideration. And imagine you have only 2 inputs. 2 inputs means you will have 2 neurons in the input label or input layer. So these are the various layers we have. Check it out here. So what is that? We will see in the form of a demo, okay? So assume that we have two inputs, x1 and x2. We have two inputs now. What? So we are not considering any bias. So you're not having any additional thing present over here. Now what is happening here? Observe what is happening. So there are two inputs and we are having two neurons in the input layer. Now I don't have any bias. All these weights are randomly initialized. So then these two happen to be your hidden layer. These two are your hidden layer. Now, the number of hidden layers may not always increasing or decreasing. Here, 3, 2, all these things are present. They may not be always like this. It may be different also. So for now, we are not taking any bias into consideration. The weights are randomly initialized. And after that, it will goes into the summation. After that, it goes into summation. So summation function is like that. So what it happens, what is happening here? It is checking the weight between this one and this one. After checking the weights, randomly initialized, it will pass through the hidden layers and it will ultimately reach, here to the activation function and integration function. So here there is integration as well as activation function. In integration, it will give you the loss values and it will be calculated and together I will get a loss, which is this one, y1. And the same thing happens for repeatedly for the others also, y2, this 2, and y3, these 3, and y4, y5, y6, all these are present. This is how the propagation happens, the forward, this is the forward thing. Now what? What happens here? The summation, I got it. That goes into activation. That will give me the output, which is y1, y2, y3. All that happens for all the inputs. Now, these weights are randomly initialized. The last y that I'm getting is my predicted value. This is the predicted value. So this is now, we completed the forward process. The forward process is done. I got the predicted value. The z that you have here is the actual value. Z is the actual value and Y is the predicted value. And this is nothing but the error or loss or cost. You can call it whatever you want. So when you subtract the actual values from the predicted values, I will get this particular concept called as loss function or cost function. Once you understood what is your loss or cost, imagine you have 1,000 observations. When you send the first record, you will get 1 loss. When you get second record, you will get second loss, so on. So basically, you will get 1,000 loss or 1,000 costs. When you aggregate all of these, you will get a loss function or a cost function. And then what you do, you will go for back propagation algorithms. Why? To update your weights. The algorithm will update the weights to minimize the loss. This is called as batch gradient descendant. This is what happens ultimately. This is how the back propagation happens. Check here. This is going back, updating the weights again, updating the weights again, updating the weights again. This is what happens every time. This is back propagation demo. And the next thing that we have is network topology. What is this network topology? The ability of a neural network to learn is rooted in this topology or the patterns and the structures of interconnected neurons. So few characteristics of network topology are, you might have multiple neurons in your output layer. You come forward, calculate the loss, go back, update the weight, and you will have an input layer, hidden layer, and an output layer. There is no restriction whether you should have only one output layer or one output node or multiple input layers. See here, the number of layers, whether the information is allowed to travel backward, the number of nodes in every layer, multiple output nodes can be there, and multiple hidden layers can be there. Anything is possible. Anything is possible here. The input and output nodes are arranged in group known as layers. Input nodes process the incoming data exactly as it is received. The network has also have only one set of weights. It is therefore called a single layer network. Data, I pass this on to the input nodes and I will give the output. There is no hidden layer. If you are not having any hidden layer, that is called a simple layer network. If you don't have any input layer, That is called as perceptron or single layer. Anything is fine. You can also call it as perceptron. And what kind of algorithm is this where you have input, output, and here? Like a input, output, and hidden. That is called multi-layered perceptron or dense network, which can handle non-linear patterns. So this is what you have to understand the thing. When you don't have an hidden layer in between, only input and output, it is called as perceptron or single layered network. If you are having input, output, and hidden layer, it is called multi-layered network or dense network. These are the things that you have to remember. See, you have hidden layer. Weights calculated in back propagation. How this is happening, you can check it out here. First, input variable is present that goes into the input layer. Input layer weights will be calculated and we will make the predictions based on the loss function and we will optimize it by updating the weights. This is what happens. This is an example provided. And you have deep learning libraries. These things you have to remember. These are the libraries which we talked about, PyTorch, all these things. In which year they have been developed? In 2012, 15, 16, all these things they have given clearly in this particular page. So see, scikit-learn is the most used one, which gives most accuracy. And TensorFlow and Keras are the most used ones. And is deep learning a holy grail? No, it is not holy grail. So here see, most of the loss functions are non-convex in parameters. And you have different minimas and you lack interpretation. You have your regression equation. What is your regression equation? Y is equal to beta naught plus beta 1 into x1 plus beta 2 into x2. You are going to predict the mileage. For suppose I am going to predict the mileage of a vehicle. You will get some input values. So what I will do is 15.1 minus 1.5 into horsepower. What does this mean? How can I interpret this one? If you increase the horsepower by 1 unit, the mileage will get reduced by 1.5 units. This is nothing but the interpretation. We lack the interpretation. Because of it, we will have explainable artificial intelligence. So you also have lack of easy reproducibility. What do you mean by that? Suppose you ran your algorithm, you got an accuracy of 98%. And when somebody asks you to reproduce the same accuracy results, it will be difficult because if you run the algorithm, you will get different results every time. Each time the kind of results that you keep varying, that is nothing but lack of easy reproducibility. So these are the things that you have to remember when it comes to deep learning. So we will talk about the other things, which is the challenges of deep learning, all these things in the next session. I hope everything is clear for you up to now. So we will meet in the next session, which is on the next next Friday. So before moving on to that, we will see the mind map first and we will close the session. So black box techniques are there, which uses the concept of deep learning. Here we are talking about neural network. What is perceptron algorithm? That is linear separable boundary, which means hidden layers are not there. You have linear relationship and every neuron is connected with every other. Multi-layer perceptron or artificial neural network. There is non-linearity separable boundary. Convolutional is there. That is CNN. It is used for images and videos. And recurrent is there for textual data. And long short-term memory. It is there. It is bidirectional again. And this is deep bidirectional LSTM. You have to learn all these things. And remaining things we will see in the next session. I hope this is helpful for you, everybody. Thank you.